Hey guys, here we go. So let's do it. Packet 3, similarity and congruence. So in class, we did this page, right? This page and this page, okay? So we just need to do this and we'll be done. Okay, so let's look at the learning goal here. It says, given two figures, use the definition of similarity in terms of similarity transformations to decide if they are similar. Explain, using the similarity transformations, the meaning of similarity or triangles as a quality of all corresponding pairs of angles and the proportionality of the corresponding sides. Okay. So we have some notes on this, and in our notebook, we can put this. You can put this here on your sheet, or you can actually write it in your notebook. All right, so what is this? 1.2, and it is SRT. So SRT, what does it mean? So it means if I took one figure, ABC, and I moved it over, and maybe I moved it down, and I blew it up, DEF. Then I need to be able to know and understand that similarity means that I could use some type of transformation, like translation, rotation, or reflection, and then dilate it. And that therefore, when I did that, these angles would match, these angles would match, and these angles would match, okay? So similarity means that the angles are the same. And it also means that the sides make the same ratio. So sides make the same ratio. Okay, so if you see here, I made this side, however long this is, twice as big. And then this side, twice as big. And then this side, twice as big. So what did I do? I did the learning goal. Let's take a look again. It says, given two figures, use the definition of similarity in terms of similarity transformations to decide if they're similar. Then explain, using similarity transformations, the meaning of the fact that they're similar, or that the triangles themselves are equal, have equal angles, at least the corresponding ones do, and that they're proportional in sides. Okay, that's exactly what we got done doing. So we just need to be able to prove that we know how to do this, and here's some questions that kind of test you on those ideas. Question 1, ABC is similar to, meaning these two angles are equal. Bingo, bango. Those two angles. And these two angles. Got it? Okay, AB is 6, all right, and AC is 8. Now, which statement would justify that these are similar by side, angle, side? Okay, so when we look at this, we have a side, an angle, and a side. So I need angle D. I need A to equal D because they're at the same spot, right? So I'm going to cross out these two. All right, now, what about if DE, I'm going to try A. So if I try A, if DE was 9 and DF is 12. So order the baby least to greatest, 6 and 8. Order the mommy least to greatest, and let's see if this is the same ratio. So this, 6 divided by 9. Six divided by 9 equals 0.6 repeating. All right, 8 divided by 12. Let's give it a try. 8 divided by 12, 0.6 repeating. Okay, so it's definitely A. Voila. Now, what's wrong with the 8 and the 10? Okay, so we could try. I could prove to you that it's not B. Let's give it a try. So this would order the baby least to greatest, and then order the mommy. They said 8 and 10. 8 10. Okay, so when I turn that into a decimal, 6 over 8, 0.75. And 8 divided by 10, I already know that's 0.80. 8/10 is 0.80 or 80%. Those aren't equal, so it is not B. Voila. Question number 2. In the diagram, this triangle and this triangle are drawn such that angle X is congruent to angle U, and angle XZY, this angle, is congruent to that angle. Okay, so they not only put them in the problem, but they also showed it in the picture. So that was nice. They took kind of a step out for us. Now it says, describe a sequence of similarity transformations that would get one on top of the other. Okay, so I think we could flip it over this line, and then this would then be here, because everybody kind of sees that. Flip, so step 1, flip over, I guess I would call this y equals x. It looks like the slope y equals x, so it's like the slope is going up. All right, flip. So flip means reflect, right? Then I need to blow it up. So it looks like it's this long and I need it twice as long. It's this long and it's twice as long. So I need to dilate a scale factor of 2. So what would that look like? X comma y. I need to double the x coordinate and double the y coordinate. Cool? Beautiful. That's it. Now, could they ask that? Not really. That's too much to type. They can't grade that. So maybe you would have a multiple choice question and that one would be your choice. Could these be, I think it's important to think about this, could these be flip-flop? Yes, I could blow it up and then flip it over. So in either of these order, I would land on top. Okay, question number 3. When two triangles are considered similar but not congruent, so that's kind of like the last one. Let's say these are similar because they have the same two angles that are the same, but they're not congruent. Now, this is an important point. I actually brought up in period 7 today, but I didn't mention in 6. If they're twins, twins are actually similar and congruent. But this is an example of similar but not congruent. So technically, a square is a rectangle, but a rectangle isn't a square. Two congruent shapes happen to also be similar, but these two shapes that I've shown here are similar but not congruent. So I've drawn a picture of that. All right, now it says, if this is true, the distance between the corresponding vertices are equal. Okay, so let's say we blew it up. Let's say we blew this object up. So this distance, and let's say we triple it. 1, 2, 3. This distance to this next vertex, and we're going to triple it. 1, 2, 3. Then let's take this distance here, and we triple it. 1, 2, 3. I have a new triangle that's just like this old triangle, just 3 times bigger. Does it make sense? So it's saying, if they're similar but not congruent, does it make sense that their corresponding vertices, the distance between them is equal? Okay, this distance is not equal. This one looks shorter than that one. So I'm thinking I'm going to say no to A. The distance between the corresponding is proportionate. Okay, that's going to be a yes, right? This distance is 2. This one is 2 over 3, 2 over 3. That sounds like a right answer. The vertices are reflected over the x-axis. Okay, that's No, reflection is rigid motion. Reflection is rigid motion, meaning it doesn't get bigger or smaller. If it's similar, it has to get bigger or smaller. Last one, each vertices are shifted up by the same amount. Okay, that's translate. And that's also rigid motion. And that means it doesn't get bigger or smaller. And for similar but not congruent, it has to get bigger or smaller. So we're definitely going to settle in on B. Okay, last question. The vertices of, all right, J, K, L. Okay, the vertices of this, find the coordinate pairs of the vertices for each dilation with a scale factor of 5. Now, I didn't have to draw it because, but I did just so we can kind of get a feel for it. If we dilated about the origin, then J, K, L would merely change by multiplying by 5. So by 5, by 5, by 5, by 5, by 5, by 5, right? So negative 15, negative 10, 5, 20, 20, 10. All right. What if you dilated it around point J? Okay, so this would now be 1, 2, I got to go all the way out to 5. It's going to fall off the page here. So if you dilate it around point J, this is too hard for me to write out the coordinates. I could, but it's a little too hard. So if I got this question on the test, I'd probably skip it. If I had time remaining, I'd go back and kind of graph it out, if that makes sense. There is a way to do this and figure it out. It's just really hard. It's really time consuming. So I'm going to stop there, okay? If you really want to know how to do this, I'm happy to answer it for you. Just ask in class. See you next time.